So today's Leetcode daily challenge is a very easy question. Final prices with a special discount in a shop. It's a ad hoc problem. So we have been given a problem statement and we simply need to implement that. There is not much algorithm involved, but let's go through the problem statement. So we are given an integer array prices. So we have been given this array. Okay. What we have to do is we have to return a resultant array, which will be the discounted prices. Okay. I will keep on coding as well, or let's call it discounted prices, and it will be its length will be same as the given vector. Okay. Now, how to calculate the discounted prices? So, suppose we are at index 0. So, for any, if I have to calculate the discount, so the discount will be on an index greater than the current index. So current index is 0. So we will find the discount for this 8 for this 8 in one of these values. Okay. Now what will be the discount? The first value which is lesser than or equal to this current. So the first value which is lesser than or equal to 8 is 4. So the discount is 4. So the net price is 4. Again, if we go through 4, the first value in index is greater than the current one, which is less than or equal to the current value 4. So 6 is greater than, so we cannot take that. 2 is less than and equal to 4, and the index is greater than this current index. So we can take 2. So 4 minus 2, 2. It's a very simple logic. So what we have to do is see, now obviously for the last index, there will be no discount. Why? Because we don't have an index which is greater than the last one. Okay. So we will be traversing on this array from the reverse, because for the last array we for the last index we already have a logic in place. Okay, and we'll need the help of a data structure called stack. So stack will help us in, so if we think of brute force, there can be an O of n square solution possible, where we iterate from the starting and just try to find out the next index, uh, which is satisfying this condition. But that is the brute force, and that would be a very easy implementation. So I'm going with the stack implementation. So yeah, I'm starting from the reverse. Okay, now for the last index, we obviously know that this is equal to prices of I. Okay, now when we are at the second last index, when we are at 2, how do we find out? So for 2 also, we don't have any discount possible, because although we have indexes greater than the current index, we don't have any value which is less than or equal to the current index. How do we figure out that? So we'll need the help of a stack for this. What we'll do is basically see the current logic. When we have initialized a stack, the stack is empty. So when the stack is empty, or basically the scenario where like we'll get the stack empty scenario multiple times, but for now this is the scenario where our last index is in play. Okay, last index, or when stack is empty. If stack is empty, that will be the scenario. If stack is not empty, then we will try to keep the minimum index which satisfies this constraint at the top, so that we can simply calculate by this. So st, I've taken st, right? So st dot top. So in stack we are holding the indices and not the value. So I'll also write this. So we are pushing indices, not value. This confuses me sometimes. That's why I'm clarifying this part. Okay, so now what we are trying to do is suppose in our stack. Uh, so this is the last value. Okay, this is our stack. Yeah, and this is the last value. With basically the like stack is the last in first out. So this is the last value. So we have pushed 3. Okay, from this line. Now we are at 2, because we are traversing in a reverse fashion. So do we have to push 2, but will this, suppose stack is not empty, right? So now in this prices of I, it will be 2, and prices of history dot top, I'll get 3. 2 minus 3, that is a negative number, and also that doesn't satisfy our constraint. We only need values which are less than or current, less than the current one, right? So what we'll do is we'll only push here. So okay, we have to pop the current value, right? So we'll have to write a logic which will allow us with this pop. So how will this pop work? It should be, so our stack is not empty, and the prices of, so the current price is 2, and that is, the current price is greater than the price present in stack dot top. So 2 is greater, 2 is lesser, right? So it should be less than equal to. So the current price 2 is less than or equal to 3. That's when we have to pop. So we are popping, and when we pop, the stack becomes empty. So the discount prices for this will also come up as 2. Now when we are at 6, the stack is empty, so we don't do any. Sorry, the stack has 2, right? We pushed 2 at the end. Now when we are at 6, we check 6 is less than or equal to the top. No, so we don't do any pop operation. What we do is we come to this else condition, and for this prices, uh, it will be 6 minus 2, which is 4, and then we push 6. So 6 comes in here. Now we have 4. We check again. 4 is less than equal to 6. Yes, so we pop 6. 4 is less than equal to 2. No, so we don't pop 2. So in here, discount becomes 4 minus 2, 2. We push 4. We have pushed 4. Now we come to 8. Uh, is 8 less than equal to top? No. So we don't do any pop operation. We come here, 8 minus 4, 4, and we push 8. So yeah, we have already found our answer. We don't have to do anything else. We just have to return the discounted prices array. Run. What happened? Oh, what's wrong? 9116 I think it should be less than, yeah. Yeah. So that's all.